All right, this week's review video is a little bit different. As you can see, I have already worked out these problems and have the answers. So what I'm going to do is just quickly talk about each one and how I got there. So if you've already completed these problems, you can just check and make sure your answer is right. And then if you get it wrong, you can listen to just the specific part of the video that you need. Okay, question 1 here, writing in standard form means I want my x's and my y's on the same side. So the first thing I did was I moved this x over and get 1/2 x plus 2y equals 6. And then I want to get rid of that fraction, because remember, standard form can't have any fractions. So I'm going to multiply everything by 2. And the only place that cancels is with the other 2, which leaves me with 1x plus 2y equals, plus 4y, because I did 2 times 2, and then equals 12, 6 times 2. Question 2 here is pretty similar. I need my x's and my y's on the same side. So I actually ended up moving this 9 to the other side. You could have done that another way. You could have moved the x over there. So I'll do it the other way. 6 equals 9y plus 2x. And then since we just want the x part to be first and then the y and then the number on the other side, you could just rearrange that to write 2x plus 9y equals 6. The answer I have up here is equivalent to that. Notice that it just has all negative signs, but you could easily change all of those to positive since you're changing every single sign. Either of those answers I would count correct. Okay, this may be kind of small for you to see. We're going to talk about questions 3 and 4 together. So for questions 3, when we're doing linear or nonlinear, remember, nonlinear, we've got a few things. First of all, if you multiply exponents, that makes it nonlinear. If you haven't, exponents, variables. If you have an exponent, that's going to make it nonlinear. If you have an x on the bottom, nonlinear. It is okay to have fractions. This equation right here is the same thing as saying like x equals 1/2 y. And remember, you're allowed to have fractions. You just can't have a variable in the bottom of a fraction. Question 4 is what we talked about today. You need to check the rates of change and that they're the same every time. So showing your work is good enough as an explanation for me, because you're just showing that it's a constant rate of change. So in table 4, I got lazy, but this is adding to every single time all the way down and then adding to on the other side, so that's going to be linear. Table 2, it subtracts 12, then subtracts 4, then adds 4, then adds 12. That's definitely nonlinear because we're not even increasing or decreasing consistently. Table 3, we're adding 4 all the way through the table and then adding 2 on the other side, which is going to give me linear. And then table 4, we're adding 2 all the way through the table and on the x side also, which is going to give me linear. Linear has constant rate of change, so you need to know that for tomorrow. All right, question 5, name the x and y intercept as ordered pairs, so make sure that you've written them as ordered pairs. These we did with the cover-up method that we talked about yesterday. So the cover-up method, just so that you remember, if you cover up the x, that gives you an equation to solve for y. You can divide by -9, and that will give you +2 for the y value. If we cover up the y value then, x gives me -6, so my x-intercept is -6, 0. Remember, I'm allowed to cover those up because it's the same thing as plugging in 0, because when I plug in 0 in either one of those spots, the whole piece is going to disappear. Okay, on question 6, I've actually just given you the answer, so I'll talk about when you see solutions, that means I need ordered pairs, so make sure you understand that. If you have to complete a table of values with a fraction, remember to use the denominator to pick your domain values. So here, because my denominator is 3, the domain values that I would want to pick for x are going to be numbers like -6, -3, 0, 3, 6, 12, 18, right? You can pick any of those numbers that are divisible by 3 for your domain values. And then you're just going to plug those in and do the work, plug it into this equation and work it out. And your final answers, remember, will look like ordered pairs for each value that you get out. Okay. This question's may have a lot to it for you, but it's important that you know all of these things. So x-intercept and y-intercept, I find those first because they both have zeros. The y-intercept is 0, comma, and then a number. X-intercept is 14, or the number, comma, 0. So that's how I picked those. And then interpret just means in context. So remember, your y-intercept is always going to be your start, and your x-intercept is your end. So that helps a little bit. And then you can just look at what the problem is talking about to complete your sentence. So you can read what I wrote for the x-intercept and the y-intercept here. And there are other ways to state those. Another solutions are ordered pairs. So another solution just means pick any of these other 4 points in the table and tell me what they stand for. So for example, this would mean after 2 hours, the pool has 8,640 gallons in it. Or you could pick another point and say after 10 hours, the pool has 2,880 gallons remaining. All right, and then the last thing is interpret the rate of change. You only need to pick 2 values to do this with. So when I completed this, I used the bottom 2 values in the table, the bottom 2 points, because I didn't have to worry about subtracting anything. 440 minus 0 is just 1440. So that is decreasing. I'll zoom in so we can see that a little bit better. We're decreasing by 1,400, and 40 gallons, while we increase by 2 hours. So when I divide that or simplify, I get negative 720 gallons for every 1 hour, which means the pool drains. Drains because the value's negative. The pool drains 720 gallons each hour, or you could say for every 1 hour. Okay, questions 9 through 12 are what we talked about in class today. Make sure that you have set those up correctly. If for some reason you're getting them wrong, make sure that you're doing correct things with your negatives. So anytime if you look at questions 9 and 10, anytime you have the double negatives, those should change to plus signs. And then if 0 is on the top, remember that means you're rising 0. So you've got a line that looks like this, which is a 0 slope. On question 11, make sure that you have done change in y over change in x. That's the most common mistake, is people get their slope upside down, so that this y change, -3 right here, has to actually be on the top. For all the parts of questions 12, notice that I have made points. I've found where the line crosses through the corners, and I've used those to answer my questions. And then we talked today about how to write a word on top of the line to remember where to start and to remember if our slope is positive or negative. You could even write the word slope to remind you need to start at the left point and move to the right one, and notice if your line is going up or down. And then we talked about how to remember 0, right? You can make a Z with the line, and undefined, you can make a U with the line. Okay, last little set on this side. Question 14, the common difference just means they want me to find the pattern. So that's what my -1.4 is. I'm subtracting 1.4 each time. And then to find the next 3 terms, I just keep that pattern going, subtracting 1.4 every time. Remember, for recursive, anytime you're writing, you have to go back to the 0 term, because that's where mathematicians start. So recursive has 2 parts. It's got a statement that says where to start, and then it has a statement that says what to do. So the f of n equals f of n minus 1, this part always stays the same, and you just finish out the equation with the pattern. So if you were adding 7, you would say plus 7 out there. You have to remember that for tomorrow. And then explicit, f of n equals -30 minus 5n. I'm just saying the starting value, and then since -5 is like the rate that it's changing by every time, it is going to include this variable n. 16, the 23rd term, I'm just plugging 23 into my explicit equation. Remember, that's the easiest to work with and solving. If it asks which term is something, then you put that value on its own and set it equal to your equation and solve that way. And then we skipped question 17, so don't worry about that one. All right, you could have done each of these a very different way, so I'm just going to tell you probably what maybe you should have done or what would have been the easiest way for each one. So for question 18 here, because y is already by itself, this would have been a good question for table of values. So all you're doing, remember they don't give you a domain, so you're just going to make a table and pick your own domain. And you could pick, remember it's always good to try to pick some negative, a 0, and some positive numbers. The problem is when you try to plug in this positive number here, you get a value that's not on the graph. So you may have to kind of work backwards and get some values that are on the graph. Number 19 is already in standard form, so that would have been a good problem for intercepts. And then we're just going to do cover-up method, and that gives me that the x-intercept is at -1, 0, so I plot that as its own point. And then my y-intercept is at 0, 4. And then all of these, because they don't give us a domain, are going to be continuous. So you want to connect those, make your line go all the way through your graph, and use arrows. All right, question 20 is a good question for table of values also, because the 3 and the 2 don't both divide into 10. So that means I need to first solve this for y. So you can take a second to do that. Originally, I got the equation on the left, but because it was negative, I just went ahead and changed my signs on the top to get this y equals 3x minus 10 all over 2. Now, I will tell you, because you're doing table of values and you have a fraction, you want to use this to pick the domains you're going to graph. So because of that, we want to pick things that are multiples of 2. So in your table, you should use numbers that relate to 2, so like -2, 0, 2, 4, 6, 8, right? You can pick any of those things. On your work tomorrow, you need to have your own table worked out to get credit for this problem, because obviously I have the answer. So you need to have your own work so that you can verify that this is indeed correct. All right, question 21 is a good question for intercepts. That's an easy problem because 6 and 2 both divide into 6. So I just divided those, got my 2 intercepts, and connected. Question 22 is already solved for y, so because of that, that's a good question to do a table of values. And there's no fractions, so you can pick any numbers that you want to, plug those in, and get a few points. And then always make sure you connect and make it continuous, since they don't give you a domain. And then question 23, again, is good for a table of values, but remember, because you've got this fraction here, you want to use 5 to choose your values. So numbers like -5, 0, 5, 10, 15, 20, those are all good numbers to use in your table of values. Either, whatever you do tomorrow, if you do a table, you're going to need to show your work. All right, and last section, and we talked about this week that discrete are things that have to be counted by whole numbers. And then continuous is anything that can be counted using numbers in between. So discrete is counted by whole numbers. So if you look here, distance, you can use numbers in between, and so can you for minutes. So that's going to be an example of continuous. Discrete, the second one, pieces of laundry has to be counted in whole numbers. So that's why that one is going to be discrete. And then money can be counted with numbers in between, and so can the number of gallons. So that one is also going to be continuous.